Alright guys, let's dive in. This is going to be our last video in Unit 2 for linear equations. We're going to talk about standard form today. Random fact, M&M of the candy stands for Mars and Murray. They were the sons of the Mars Company and the Hershey Candy Company's founders. That's where the M&M comes from. Alright, let's dive in. Let's start with slope-intercept form today. It's something we've been working with, and I want to make sure you guys are clear on this. When we talk about slope-intercept form, okay, we've got it color-coded here. Slope is always right here next to x, and your intercept is that constant, the constant term by itself, okay? And notice in slope-intercept form, this is really important, the y value is by itself, okay? We call that an equation that is solved for y. And when we say solved for, we just mean whatever is on the single side of the equation by itself. So in this case, that equation was solved just for y. Okay? Now, right below that, we've got that original equation in slope-intercept form. Then down here, we've got standard form. And standard form, if you notice, has the x and the y on the same side of the equation, which means it is not solved for x, it is not solved for y. They are together mixed in on the same side of the equation. Now, both of these, this slope-intercept form equation that you see and the standard form below it, they're the exact same equation. They're the same function. They both make this graph that we see right here. Okay, they're both that graph, and we can see there's its slope-intercept of -3. We see that. And then there's a slope of 3/4. We can count up 1, 2, 3 over 1, 2, 3, 4. We can see there's a slope. So it's very easy to see that that graph has a slope of 3/4 and an intercept of -3. It's very easy with slope-intercept form to see the graph and that equation match. We can see why the equation makes the graph. We can pair them up very easily. Well, it turns out that this standard form is the exact same equation. It's the same exact function. If they gave us this equation in standard form, though, do you see the slope? You know what, why don't I use the same color code? Do you see the slope of 3/4? It's not there. There is no 3/4 in standard form. And do you see the y-intercept, also known as b? Do you see the y-intercept of -3? These two pieces are what make up that equation to be able to solve it, or graph it in slope-intercept form. But they're not in standard form the way it looks right now. There is no -3 and there is no 3/4. So we have to be able to rewrite standard form if we're given that, if we want to be able to unlock this quick, easy way to graph the equation. Okay, that's what we're going to do today. Now, if you're thinking about it, which hopefully some of you are, you don't have to rewrite it to graph it. If you're given an equation, you can always just go to old school t-chart. You could just plug in some values like an x value of 1 and then just rewrite the equation, replace the x value with 1, and now you've got a two-step equation to solve. So you can do the work and solve it down and get the y by itself. But that seems like a lot of work to get one answer. And then you have to plug in another value, and you have to plug in again and solve another two-step equation just to get a second point to graph that line. So you can go that route. You're always allowed to go that route with any function. You can just plug in an x, get the y. But when this simple form, like slope-intercept, exists, why not instead just rewrite something from standard into slope-intercept and then quickly and easily graph it? And it's very easy when it's in that new form to see what you need. All right, let's do that. This really is the key. Slope-intercept form is solved for y. That's the important thing to do. We want to get the y. So how can we rewrite from standard into slope-intercept form? So we can say, you were given this problem and told, go ahead and rewrite it into slope-intercept and then graph it. Or you might be just told, graph that equation. You're going to want to rewrite it into slope-intercept. And by the way, both of these are the same one. Notice they're both just 12 equals 3x minus 4y. I'm just going to start solving and show you that you can go about it in two different ways. Whatever makes more sense to you, feel free to use. All right. Now, to jump back by itself, and once it's by itself, we're going to have this at the end of our problem, or it might be the other direction. It might look like this at the end of the problem in a minute. That's what we're trying to get, okay? When the y is by itself, everything else will fall into place. So, what are we going to do? All right, first thing, here's our y, and notice it is definitely not by itself. Okay, so we need to get the y term by itself. And actually, remember, that means you don't start, well, you could start with the y term moving it around, but I'm not going to. I'm going to actually get rid of the x term. If we kill off that x term, it's a positive 3x. If I just subtract and cancel off the whole minus 3x, in just a minute, the right side of the equation is almost solved for y by itself. All I'd have is that negative 4 coefficient to deal with. So step one, we're going to minus off the 3x. I'm not going to write it underneath the 12 though, because those are unlike terms. You can't take a 12 and subtract a 3x from it. But because I did it on the right side with canceling the negative 3x, we canceled minus 3x off onto the right. We have to do the same on both sides to keep the equation balanced. So we're just going to move it over. That 12 is still there. The minus 3x is also there. And that 12 is positive, so we're going to put a plus in. Okay, so there's step one. After one step, we move the 3x term over, and we have the negative 4y. Step two, we need to get rid of that negative 4. Our goal in just a minute is to have the equation solved for y, so it's only y on that side by itself. And this is, hopefully you guys are remembering all this. This looks really obvious. It's very much just like solving equations. I'm just dividing off the negative 4. The 4's cancel, the negatives cancel, and I'm going to have y by itself. But notice on the other side, there are two terms. And just like you did with fraction busters, if there are multiple terms in a fraction buster, you've got to multiply each one by that 3 or whatever you're trying to bust. Well, here, since we're dividing off that negative 4, normally we would divide off the negative 4. There's only one term left on the other side, and you're finished. But because there's an x and a y, there's two terms on the other side. Just make sure you divide them both. Okay? Just like a fraction buster, we're dividing each part of the equation by negative 4, so make sure each term gets divided. Okay, so right here, we've got 12 divided by negative 4, negative 3. Here, we've got negative 3 divided by negative 4. Pairs of negatives cancel. And we've got 3/4 x. And lo and behold, those two steps give us an equation that's in slope-intercept form. Okay, the y is by itself. We can now see the slope. We can now see the y-intercept. Now, on the other side, I just wanted to point out, this may look a little foreign to some of you guys. All of our equations in slope-intercept form for this unit have had y over on the left. So y over on the right might look a little weird to you. So let's solve this other one. We're going to do it again. And if you want to, you're free to just move that y term over. I can add the y term to start if I want to. And move it to the left side. So now I've got 4y over on the left side. Because again, I had a negative 4y, added it. Make sure you do the same on both sides. But the y and the 12 are not like. So you're just adding it as a 4y over. Okay. Now, I'm going to do two steps at once, and hopefully you guys are tracking with me. If I leave the 12, this is going to be what I have in a minute. So I'm instead, because I don't want the 12 and the y on the same side, if I really want the y on the left, I've got to move the 12 over to the right. So I'll just do two steps right up at the top. I'll minus that 12 off and cancel it. Okay, and again, this should look familiar. It's just like solving equations. And I'll put the minus 12 way over on the right because there are no other constants. There's nothing to subtract the 12 by. It's just getting moved to the right. And in that one step, or two steps actually, we've moved the y term over to the left. We've got the other two terms on the right. And if you guys notice, it's in the exact same place, except the signs are reversed. It'll all work out by the time we get to the end, but right now the signs are reversed because they're on different sides of the equation. Okay, last step, I want to get that y by itself, so I'm going to divide off the 4. And remember, here's another chance to practice and remember. It's like a distributive dividing, so make sure the 4 is divided on all terms. We get here, we've got 3/4 x. The negative 12 divided by 4, negative 3. And notice we're in the exact same boat. We've solved it so that y is by itself, and it's now in slope-intercept form. Okay? So there were really two steps here. Number one, you want to get this y term by itself, whether that's from canceling that x off, or on the other side, I want to get that y term by himself. So I moved him over, and I canceled off whatever was on that side. If you really want your y term on the left, feel free to move it across and move everything to the right. However makes sense to you, but you've got to get the y term by itself, other terms across. Okay? Once we do that, second step, you're just going to divide off any coefficient so that that y is by itself, and make sure you do it on both sides. It's just like solving a two-step. There just happens to be two variables involved. You've got to keep doing everything to both variables. Okay. Now, we're going to try this one on the left, and then I'll let you guys do one on the right. So to start, step 1, right here, we want to get the y by itself, and I'm going to say, go ahead and cancel off the x term. Okay, right now, copy down that problem, and then you're going to cancel off that negative 7x to move them to the right. Okay, go. Pause it if you need to. All right, I'm right behind you. Pause if you need to and you're not there yet. I'm going to cancel off the x. And notice, by the way, I didn't point this out on the other page. We are not trying to separate the x from its negative 7. We're not dividing off the negative 7 like we would when we're solving an equation for x. Okay? Notice we're not solving for x. The x is just getting moved, the whole term. The negative 7x, all of it is just getting canceled. We're not trying to split those two apart. We want to keep the negative 7x as one term. Okay, I'm just moving the whole x term across. Now when I rewrite, I'm here. Some of you may have put this 7x in front of the 20. Totally fine, it doesn't matter. So now after that one step, we're here. Now you guys need to get y by itself. So if you're not with me yet, copy that equation and get the y by itself. Don't forget, you have to distributive divide. Just like a fraction buster, every term's got to get that 5 to divide. Go. Okay, I'm right behind you. I want the y by itself. That's why we're picking 5. And after those two steps, I got what I wanted. I got y by itself. I'm going to divide the 5 on both of those. Negative 20 divided by 5, negative 4. And then plus 7/5 x. And notice, if it's up on top of a fraction, or it's next to the fraction, it's the same thing. Remember, any whole number is multiplied straight to the top of a fraction if you multiply anyway. But when we're solving something and we see it in slope-intercept form, we're used to seeing this. We're used to seeing the x next to the fraction, but this is exactly the same thing. Both of these have 7/5 as their slope. Okay? But I would get used to rewriting it this way. It's good for you guys to understand and do that. All right. Now, go ahead and do the other one on your own, start to finish. Solve it for y, pause it, and I'll do it behind you once you're done to see if you got it right. All right, we're back, assuming you gave it a shot. Now, I'm going to leave y on the right-hand side just because it's less work, and frankly, it's good for you to get comfortable solving the equation with y on both sides. So I'm just going to move that 14 next, the negative 14x. Now I'm going to cancel it. It's going to become a negative 14x on the other side. And I'm You know what? And I'll do 2 steps at once. I'll cancel the 18 over. Oh, never mind. I'm not moving y, I'm just moving x. Haha. Psych. Never mind, you guys don't need to do that. I can leave it on this side. There we go. So we got those 2 terms together. All that's left is the negative 6y. That one step, we got it by itself. Now I'm going to get that y coefficient dealt with as well. So I'm fully solved just for y. And I need to distribute, divide both. Pair of negatives cancel. That's going to equal 3. Pair of negatives again are going to cancel. I've got 14/6. I'm going to reduce that. 14/6, we can divide a 2 out. It's going to become 7/3. If you do need to graph something, it's going to be way easier to graph 7/3 and 14/6 because you don't need near as much graph space to count and over, and so you want the smallest slope numbers as possible. So I'm going to reduce that to 7/3. There's my x. That 3, that 18 divided by 6, since the negatives cancel, is positive. You need that to separate those terms, so put it in there. And there you go. All right? Hopefully that's making sense. Now, I want to point something out to you guys real quick that you need to practice on the next page. Slope, remember, is always what's next to x. You've got to look for where that might be. As we start rewriting these, things are going to move around, okay? But next to x is always your slope. By itself is always your y-intercept, once you're into slope-intercept form. Once you're solved for y, value by itself is the intercept. You got to look for that, and you got to be okay seeing it solved with y on the left or y on the right. It's all the same thing. Notice, guys, whatever we end up with, like on the one you just did, 7/3 as a slope, 3 as an intercept. Look at your original standard form. There is no slope or intercept visible. There is no 7/3 for a slope. There is no 3 for an intercept. So there would be nothing you could circle or work with there. That's why we're rewriting it. All right, so here we go. Let's have you circle the y-intercept. Okay, you've got 6 problems here. Some of them are in slope-intercept form. Some of them are in standard form. And if it's in standard form, there's nothing to circle because you can't see the y-intercept yet, okay? So if we jump, so you're going to circle your y-intercept and then put a square around your slope. And remember, you can only do that on something that's solved in slope-intercept form. All right, go. Okay, you're done. I'm assuming you've paused and unpaused me. I'm going to look right through. Okay, first one. This guy is solved for y, therefore is in slope-intercept form. So I'm going to circle my y-intercept right there. You should have circled the negative. And I'm going to square my slope, which is right there. Number 2, that's in standard form. There's nothing to see there. I'd have to rewrite it to find anything. Number 3, solve for y, so it's slope-intercept form. There's my intercept, it's the positive 7. And there's my slope, the negative 2/3. It's with x, okay? 4, nope, that's another one in standard form. Nothing to see here. I'd have to rewrite it to get anything useful out of it. 5, solve for y, so that means it's in slope-intercept form. I should write that. I hope you guys remember it. So again, my slope is a square. That's with x. My y-intercept is circle, so the y-intercept is the value by itself. And last one, that is standard form. We would have to rewrite that because, again, the x and y are on the same side. All right? So hopefully that's getting you guys used to the various ways you might see slope-intercept form and be able to quickly and easily identify slope-intercept versus standard. Okay, let's put it together, which is your homework today. Now there's 2 pages. This first page, you're going to write the equation in slope-intercept form if need be. So you'll look at them, and if they're in slope-intercept, go ahead and graph it. That's part B. If it's not, you need to write it in slope-intercept and then go ahead and graph it. Okay. I'm going to actually do the answers to the homework right here for you because I think that would be helpful to make sure you guys are getting this. So go ahead and pause this, and at the end of your homework, unpause, and I'll walk through all of the homework problems so you can see if you're getting them. And yes, of course, you can cheat, which is not going to help you come quiz time. All right, pause it. Okay, you're unpaused. Let's dive in. Both of these, I'm sure you noticed, were written in standard form, so you're going to have to do work before you can graph them. I'm going to move that 15x over. So now I've got the negative 3y. And I want to get rid of that negative 3 to get the y by itself, get its slope-intercept form solved. And I want to make sure to distribute that negative 3 to both terms. So I end up with negative 3, which by itself means that's the intercept. And the negatives will cancel, giving me a 5 with x, which is going to be my slope. So to graph this guy, my slope, or m, is 5. My y-intercept, or b, is negative 3. So we'll just graph that guy right now, down negative 3. And then a slope of 5 means up 1, 2, 3, 4, 5 over 1. There's my second point, and there's my line. Okay, so there's problem 1. Let's look at problem 2. Same thing, I'm just going to add over that 2x. And now I'm going to get rid of that 8 to get the y by itself. Two over 8, I'm going to reduce to 1/4. It's next to x, so there's my slope. And negative 8 over 8 is going to become negative 1. And we've got a slope of 1/4 and a y-intercept, or a b, of negative 1. And we'll graph him in a new color. We'll make him green for number 2. So b is negative 1. So there's the intercept for my second one. And my slope is 1/4. So up 1 over 4. 1, 2, 3, 4. There we go. Oops, that was terribly not straight. And there you go. There are your 2 equations rewritten into slope-intercept and then graphed. All right, part 2. Look back real quick on this last one. If I have an x value of 0 and a y value of 8, that point would go right here. It's already on the y-axis. That is my y-intercept. Makes it easy. Second page, write the equation of the line given the 2 points. I think this is something we need some work on, so we're just going to continue to practice that. And this here, remember, y value is on top. Okay, we're doing slope. So I draw the arrows like this, x value is on bottom, and we always subtract to find the distance between these points, between these y values and between these x values. So it's going to be negative 11 minus 8 and negative 7 minus 0. And don't forget, as always, that's really just 2 groups of bad guys. Hopefully we've got that habit by now. Those are just 2 groups of bad guys to add together. That's negative 19. Negative 7 minus 0 is negative 7. Pair of negatives will cancel. So there's my slope, 19/7. I'm halfway home. And of the ways to write the equation, I'm going to look for the easiest, which is method number 1. I'm going to check, do either of my points already give me the y-intercept? Lo and behold, it does. An x value of 0 means the y value of 8 is my intercept, right? So my intercept is the 8, and I just need to write my equation. Slope, 19/7. Intercept of 8. Wow, that was easy. There you go. Second one, let's do it again. And of course, you know this one won't be as easy. My y values 2 minus 4 on top. X values negative 5 minus 5 on the bottom. 2 minus 4, negative 2. Negative 5 minus 5. Bad guys and bad guys, negative 10. We'll cancel those negatives, we'll also reduce it. So there's my slope. We're halfway home. We got 1/5. But when we look, of course, we can't get lucky twice. There's no 0 for x, so we have to find the intercept. It wasn't given to us. So this is where you're going to plug in. You're going to take the y equals mx plus b. And we're going to plug in the slope we just found, which is 1/5. And now the x and y value, we're also going to plug in. And you can pick either point. I'll pick the first one for no particular reason. So I'm going to take the x and y value out of the first point and plug those in. The y value is a 2. The x value is a negative 5. And then plus b. So we just filled in 3 out of the 4 variable unknowns. So now this just turned into a two-step equation that you're solving for b. It's something we've done a lot of times. So let's do it. Remember, you multiply whole numbers straight to the top of fractions. So it's just going to be 5 times 1 is 5 with a negative over 5. Well, that worked out well. Bring down the 2 plus b. And this thing is getting really, really simple really quick. So it's actually just 2 equals negative 1 plus b. Add that 1 to cancel it on both sides. It's getting a little tight at the bottom. We end up with 3. 3 equals b. So we've got our slope, we've got our b. Don't forget to rewrite it and put it all together. Slope of 1/5, b of 3. There you go. There's your second equation. All right. Peace out, guys.